Welcome back to Startup Hack. I'm Spencer Thomason, and with my 25 years of development experience here at Startup Hack, we turn beginners into full-stack developers in as little as 3 months. Today, we're diving into async tips that every developer should know. All right, let's jump right in and go to the every async tip that C# developers need to know. This is going to be a great video because this is one of the great ways to really improve the performance of your application. As a .NET developer, you're probably familiar with the most concept of the asynchronous programming. This powerful technique allows your code to perform multiple tasks simultaneously while slowing down the overall performance of your application. If you want to take C# asynchronous skills to the next level, you've definitely come to the right place. All right, so going async means commitment. It's not a good idea to mix synchronous and asynchronous code without a good reason. Doing so can lead to deadlocks, especially if the context is not flowing as expected. When you start an async operation, you should propagate it all the way up and down your call stack. So if you're, as with a lot of things, if you're going to go all in. So let's dive into some code really quick. So actually, we're going to run through some of these examples first, and then we will talk a little bit more. And so we're going to talk a little bit about this code here. So as with everything, you want to really embrace it. So you want to go all the way, and you want to make sure that all of your tasks and so if you actually run something, you want to make sure that your calling method also is using async as well, because that's how you can definitely run into some deadlocks. Now, we also want to use value task over just a regular task. And so value task is a streamlined and efficient cousin of task. It is a lightweight structure that uses less memory for operations that are completely synchronous most of the time. So consider using value task if performance benchmarks justify the optimization efforts. Now, we also want to make sure of configure await, right? And so when you don't need to continue in the original context, you can use configure await false to help mitigate the risk of deadlocks and improve performance by avoiding capturing the synchronization context. Now, are you lazy? Now, of course, all developers want to be lazy, right? We always want to hire those developers, and we want to be lazy. But you can implement asynchronous lazy initialization by using lazy task class. This is great for scenarios where you have an expensive resource that you don't want to use at an application startup. So you would use a lazy class to load it later. Now also, and we're going to get to some code samples at the end of this with all of these. And so, bear with me then as we work through some of these code samples. Or as we work through these slides, and then we're going to get into the code samples. Now, and then with Always, make sure that you download the code samples. We have hundreds of code samples that we provide free, and so make sure you go and download those. And there's even a link to previous code samples, and I think between the two we're at almost 400 different code samples. So anyways, back to what we were talking about here, the async stream for the win, right? When working with streaming data, consider using C#'s iAsync enumerable T feature. This allows you to consume elements asynchronously as they become available. This is perfect for processing large data sets or real-time data feeds. Now, the async method can also be difficult to test, as exceptions thrown within them can terminate your process. It's also preferable to use async task for asynchronous event handlers, as it provides easier exception handling and testing. Now, we want to be careful of thread pool starvation, right? So make sure that your long-running CPU-intensive tasks don't take up too much of the thread pool. You can use task.run to move them to background threads, leaving the thread pool for free for quick I/O-bound tasks. So let's dive into some code samples and dig into what we talked about in some of these today. All right, so again, as always, our code samples are runnable, and we try to make these really useful for you guys. So in this case, we have a write line to see the async tip demo. So I'm going to go ahead and fire this up so that we can watch this guy run here. All right, so we ran to that point here. And let's see if we can make this a little bit bigger. So we can see the beginning of this, right? And then as we go to step through this, we're going to go to, and as we go in to look at this, we can go look at the implementation here. And you see that we're making a call out to something to get a set of to-dos, right? Now you'll notice the task, right? And so the async keyword as well as the await keyword are these important keywords where we're using async and await to get these, to make this asynchronous call. So that way our code can continue to run while we go to get this data. And so it comes back and we'll write this data out here. So then we're going to write that data out. You can see that JSON that we got here, right? So now, this is the avoid async void. And so we don't really want to use the void in the asyncs. We want to make sure that we always try to return a task. So this task is actually returning void. And so it's just, this is a simultaneous, it's simulated, right, for our code sample here. And then we write async work done, right? So we're going to go back to that up here, and we're going to run this, and you'll be able to see it. Let me get these windows situated side by side so we can see them a little bit better. All right, now we're ready to run these guys side by side. So as I run this, you can see that it says async work done. Now, the important part here is that we always want to try to make sure that we return some data. We want to try to avoid returning just a blank task or a void task here. Now, we can also use the configure await false like we talked about, right? So here, we're going to see an example of where we can go to see the configure await false. So you can see it says, hey, don't wait for this, right? And it's going to return this task. So let's step through this. Oh, so we ran over that one, and you can see that it came back, and it didn't say to wait for it. And so as we run this next one, we'll see that other one pop through. So we can see that all tasks are done, right? So this ran when all, and it came back when all the tasks were completed, right? And so this is the when all and when any. Let's go take a look at that implementation here. So what we can see here is that this ran, and it says when all the tasks are done, then it came back when only once all those tasks have finished. Because there's a lot of times that you do need things to run into certain orders. And so in this case, we were just simulating these, and then once it came back, it said all tasks completed. All right, let's keep going here. So now we can see this next one. Oops, and I think we just moved past it here. So we can see that this next one is running to use semaphores for throttling, right? So we see that we ran through all of these ones to use as a semaphore as we use the semaphore to wait through all these. And you can see that it uses the wait async keyword. Now, it's going to give a range of enumerables of 0 to 5, and then we're going to use link to run these. And as we do wait async here, it'll wait for that to come back. Then we have a temporary delay built in here, so you can see all the tasks, and you can see what order they came back, and these all came back, and then the whole thing returned once we were finished, right? And so you can see that they didn't necessarily come through in order, and so this allows us to see that it fires them as they go, as they came back and completed. All right, next here. As this one we're going to avoid blocking calls, right? We want to be careful to make sure that we aren't blocking, right? And so this is going to return a non-blocking call. So this is going to return a task of a string. And so let's put the breakpoint down on here, and we'll run to this point. So now it's going to wait, and then it came back and ran that. Okay, and so that's where we can see that this is we want to avoid these blocking calls, because when we run these, you notice that even though it returned this non-blocking call here, we can see that we want to be careful to make sure that we avoid any of these blocking calls. And so this is an example of kind of what not to do. All right, lastly here, we can see as we loop over each of these async over the enumerables, right, we can use this async, which is going to give us a thread-safe way to do this, so that these can write in sync and it gets these numbers async, right? So let's go here to the definition. So we can see, and it's kind of hard to see, and so I'm going to shift these screens just a little bit here. So we can see this loops over, and it does a delay on each one of them, and then returns with the keyword yield to return I. So let's run this next code sample here. You can see it's running through each of these and then keeps them in order as it's running through. And that's actually the end of our code there, so it completed. But we can see that in this case, it's actually keeping that thread safe, so that these async enumerables are thread safe as it's working over those, right? Because it's working over each of these items in a thread safe way and then writing these out. So this is really important, because we want to make sure that as we're working through these, that as we do async, things sometimes need to happen in a particular order. So we want to be careful to make sure that we don't do things out of the incorrect order. So let me know what you think about our videos. I'm definitely always open for input. Here at Starter Pack, we love training software developers. And so make sure that you like and subscribe to the channel. Leave a comment down below. Hopefully, and make sure you pull down these code samples. These code samples are very helpful, and you can use these in a lot of your operations or as you're teaching. So we will catch you guys next time. Make sure you like and subscribe to the channel because we bring you lots of great tutorials and tips that every developer should know. See you next time.